Okay, class, so welcome to today's lesson where we're continuing on with our inequalities, and we're going to learn that I actually lied to you. There's one difference with inequalities that compared to equalities when you're solving. And we're learning about that today as we go through our checklist and see when this case applies. So one thing to keep in mind for today and also for your homework was that the word that we don't really do checks for inequalities. What we do is we change that word to a verify. When we verify, what we're looking for is we're looking for a true statement. Okay, a true statement. And what makes a true statement? Well, what makes a true statement is that the sign eats the larger number. So you're looking for true statements, sign eats the larger number, makes that true. So for example, something like 3 greater than -2, that's true because the sign's eating 3, which is greater than -2. Sign's very hungry, always eats the larger number. So as we look about these rules, we're going to try and do a little check things out to see what makes things true, what makes things not true. So if we add 2 to both sides, if we went +2 and +2, we would get -3, sign stays the same, and 12. Is that a true statement? Is the sign eating the large number? True. So we got no problems when we're adding a positive. Okay. Then what we're going to do is we're going to subtract 3 from both sides. So we will go -3 minus 3. We get -6. Sign stays the same. And we get 9. Is that a true statement? It is true. So when you're subtracting a positive, there's nothing wrong there. Now let's see what happens when we add a negative. So we're going to go plus -2, plus -2, and so we get -8, sign stays the same, and 7. Ooh, is that a true statement? Well, we got +7, and that's a lot bigger than -7. So yeah, it's still true. So when we're adding a negative, no big deal. It's still true. We can still do that. Well, let's see what happens when we multiply by a positive. So times by +4. So we're times by +4. What do we get? We get -32. And here we get 28. Is our sign eating a larger number? Still is. It's still true. So there's no problems when we multiply by a positive number. Okay, then. Let's divide by 2 on both sides. So divide by 2, we get -16, sign stays the same, and 14. Are we having the sign eat the larger number? Is that true? Yes, it's true. Okay, remember, if this is 0 right here, 14 is way over here, and -16 is way over there. This is a lot larger. All right. Okay, so let's take this now. Let's divide by -2. So we're going to divide by a negative. Divide by a negative. Now we get +8 and we get -7. Is that a true statement? Is it? What do you think? Here's 0. Here's -7. Here's +8. And the sign's eating -7? That's false. That is not a true statement. So we had a problem when we divided by a negative number. Okay, well, let's go back to our true statement that we had the first time. So let's go back to our original. Squirrel. Our original was -5 and 10. -5 and 10. And the sign was eating the 10. So that was our original question from the very top, which was true. So let's multiply that by -3 times -3 times -3. Now we get +15, sign stays the same, -30. Well, here's our number line. Here's 0. Here's positive 15. Here's negative 30. And the sign's eating negative 30? What? It's way down there. This is also false. So what we did, we multiplied by a negative, and we divided by a negative. Then we got false statements. That's a problem. So what could we do to fix it? What would have made those true statements? Well, what would have made a true statement? Well, if our sign was different. So what would be a rule that we could come up with? Okay, so the rule is if we multiply or divide by a negative number, then the sign would have to do what? The sign needs to switch directions. So a less than will become a more than, and a more than will become a less than. Or if it's more less than or equal to, become more than or equal to. So we won't really change the whole sign, just the direction. So this changes to this. Okay. And if you have this part, that one changes to that one. Okay. That's the only thing that we have to worry about. I'll give you a hint. For grade 9, all we really focus on is this one, because most of the time that's all we're going to do is divide by a negative at the very last step. Okay. That's my other little trick that I'll kind of let on to you, is that it happens always on the last step. And that's because that's our step where we have to multiply or divide by the number in front of x. Okay, so you only have to be careful in the very, 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 very end of our question. So let's go over some examples now. Okay, we're going to see some harder examples in our homework. We always say move negative 3x over, so we move the smaller one. That one's smaller than 5x, so let's move that over. Plus 3x. Now, some people may not like to do that because we always want to say, hey, let's have x on that side. Well, we'll have the exact same question here where we solve the 5x over. So let's just leave that for now, but let's go and move the smaller one. So add 3x, and we get 7 greater than 8x minus 17. Move 17 over, we get 8x, and we get 24. Divide by 8, and we get x. Now it's a positive 8 we're dividing by, so we don't change our sign. Don't make stuff up. Okay. What you got to be looking out for is a negative 8x. Then you'd be dividing by a negative 8, and then you change your sign. We're not doing that. We're dividing by a positive. Now, I always say you want x first because this is hard to say. How would you say that? 3 is greater than x? Well, wrong. You have to start with the letter first, so let's then start with the letter first. So we have x and 3. Now you'll notice the sign is eating the 3, and it's food specific, so we don't want to barf on our page and get sick. It must eat the same food in order to not get sick. So when we flip-flop, we have to keep the sign eating the same number. X is less than 3 because that makes the letter L. Okay. Sideways L. Get it? Haha. Tricky, tricky. So now that we have x first, we can graph it easily, we can say it easily, and we can show it easily. Okay, what's our boundary point? What goes in the middle? Correct, 3. One number higher? Correct. One number lower? Correct. Open or close circle? Well, remember it's less than, so we have to show that the number is interesting, but it's not an actual answer. So we have to use an open circle around the 3. Shade left or right? Well, what numbers are less than 3? Well, the less than 3 are all those numbers to the left, like 2, 1, 0, negative 1. Those are all possible answers. Okay. So there we have it. That's easy for us to do. But what if, like I said, some people just always want x on this side because they don't want to have to do this step where they have to swap them. And that's totally fine. So if you move 5x over, you would just have to do the opposite of 5x. So you wouldn't look here, you would look in front and see it as a positive 5x. So the opposite is minus 5x. Now don't get too concerned here. We will get a negative 8x. So you got to be really good with your positives and negatives. That's why we practice with it the very first unit. Okay. So our 5x's are moved over to the left side. Now we move the 7, minus 7. So we're left with negative 8x. Our sign must continue to stay because we're not doing anything different. We don't change our sign when we're simply subtracting. We saw that up here, that when you subtract, where is it? When you're subtracting or adding negatives, see, this is no problem. You got true statement. So let's go and finish the sucker off. So we get negative 24. Now you'll notice here, oops, pardon me, one more up. You'll notice here we have 2 positives, but here we have 2 negatives. That's okay though, because what we're going to do next is divide by negative 8. Divide by negative 8. Now Mr. Barker's super talented, never likes to make mistakes. As soon as he writes down divide by a negative, guess what he also does? Changes his sign. Okay, changes his sign. Do that right away. Now, guess what? Voila, I am left with positive x because I have a negative divided by a negative. And over here, I'm not going to get negative 3, I get positive 3. So I get the exact same answer if no matter which way I solve it. But one method, right? One method, you have to flip it and do an extra step. No big deal. The other method, you get it right away, but what do you have to do? You have to flip your sign. Okay, so you gotta change your sign. And that's okay. And guess what? Mr. Barker, super smart math teacher he is going to force you to do questions like that, and we're going to force you to do questions like that. I'm going to make you do both. So practice both. Okay? All right. Let's verify. Let's verify this one really quickly. Verify. What number should you choose? Okay, so first of all, what number can't you choose? You can't choose x equals 3. You can't do that. You can never use your boundary point. It's not an equality. So you want to use something from that statement, x is less than 3. So what number can you use? You can use 2, 1, 0, negative 1, all of them. I don't care. I'm going to choose x equals 2 because it's the next number. So I'm going to substitute in after I write the original question. Negative 3x plus 7 greater than 5x minus 17. I'll substitute in using brackets, of course. There's 2. Okay. 5 times 2 minus 17. So notice I'm not writing the Great Wall of Czech. I'm just doing my inequality sign. But I have a question on the left and a question on my right. I don't go back and forth. So here I get negative 6 plus 7, and here I get 1. Here I get 10 minus 17, and I get negative 7. Is that a true statement? Yes, it is true. Okay, so that is a true statement. So I verify that x equals 2 is a solution. So I graphed it properly. If you looked over at your graph, I graphed it properly, and I answered it most likely correctly. Okay, good. It's a little bit weird with the verifies and checks. Totally understand that. No big deal. Okay, and now for a very last question. You try it and see if you can solve it first and then check back. Go. Okay, now that you check back, make sure you multiply in. So 6x minus 15, sign stays the same, 9x plus 27. So you can, I'm going to show you how to solve it both ways. So just to let you know, 6x minus 15. Actually, let me just make this a bit smaller over here. So 6x minus 15. I know my signs don't line up. I'm breaking my rules. But I just want to make sure this fits in one page. So 6x minus 15, 9x plus 27. Now, I know you guys like to move more than one thing at a time. Sometimes that happens. I totally say don't. So easy to make mistakes. Okay, so I'm going to move my 9x over. Minus 9x minus 9x. I'll get 3x negative. Haha, almost forgot that. 27. And then I'll move my 15 over. So I'm adding 15. So that'll be 30, 42. And then I'm dividing by what? By what? So I have to change my sign. Dividing by a negative. Okay. I believe it's 42 divided by 3. Too early for me to think. 14. So when I'm dividing by negative, I get negative 14. There you go. Okay. Go ahead and graph that. All right. If you solved it for the other side, that's fine, right? So you look in front of the 6x. That is a plus sign. We don't write it. So the opposite would be a minus a 6x. So if we wanted to move negative 6x, because it's the smallest one, you're totally welcome to. 15 is negative 15. You must keep that sign. You can't screw that up. There's no reason to change that, so it must stay exactly the same. There's no reason to change it. This becomes a positive 3x plus 27. Now I'm going to minus 27. And it's just a negative number that you're adding or subtracting, wherever you want to think about it, but it's negative 42. Okay, now 3x is positive. So then when you divide by 3, not negative 3, divide by positive 3, you're going to get the same answer. Your sign is still the same. You'll see that these are exactly the same. There's no difference between them. The sign is eating the x, the sign is eating the x, the sign is eating x, the sign is eating the x. But to graph this one is challenging, and to say it properly is challenging. So what we need to do is rewrite it so that x is first and negative 14 is on the other side. Now remember, if the sign is eating the x, it's food specific. It must eat the x when you flip-flop them. So it must then flip over. Okay? And now you can see the answers are the same. This format's easy because it's telling you to shade in that direction. Right? You can see the signs now matching up on top of each other. There you go. That's shading that direction. The sign tells you the direction to shade. It's like an arrowhead. So now that you have that, graphing it, negative 14 is in the middle. What's one higher? Be careful, you have negative numbers. What's one higher? You're right, negative 13. What's one lower? Negative 15. Weird because they're negatives, but you got to watch your order of your negatives on your number line. 0 is way up here, okay? That's where 0 is. Good. Open and close circle. Well, you have the equal to part, so this must be a shaded in circle or closed dot, whatever you want to call it. Shade left or right, well, the sign's pointing that direction, so you shade that direction. There you go. And that only works, that shading in the direction thing only works with X being first. Okay? Full meal deal, full answer. There you go. Enjoy your homework.